Standard 6.3, converting between rational exponents and radicals and simplifying related expressions. All right, so for this particular standard, you need to be familiar with the rule that if you have some base, let's call it a, to a fractional exponent, such as m over n, we can rewrite this as a root. We call this the nth root of a to the m power. Now, when we write it this way, we do the power first and then take the root. Or you can write it as the nth root of a, which says we take the root first and then raise it to a power. Either one is fine. One is just sometimes more convenient than the other depending on the problem. What we have on the left here is what we call exponential form. And on the right here, both of these are called radical form. And this number n is what we call our index. Now, ever since elementary school, you've been using this symbol, which is square root. And the index is never written for square root, but the index for a square root is actually 2. All right, so for our first example, or first few ones, we want to convert from one form to the other and then simplify if possible. So this is going to also require some knowledge of Standard 6.1 using exponential properties. So if you need to, go back and watch those videos first. So in example 1, we have a product raised to a power. So what we're going to do is we're going to take our product and raise each factor in there to the power. That's the product to a power rule. So we are allowed to make this 64 to the 1/4 power times x to the 1/4 power. Oh, I'm sorry, that's not what we're being asked to do. We are being asked to convert it to radical form. So if we convert it to radical form, notice the 64 and the x both get the 1/4 power on it. So 64 and x both go in our root symbol. And 4 becomes our index. And 1 is our exponent. Now you don't need to write power of 1. So it's the 4th root of 64x. All right, let's look at our next example. By the way, you could potentially simplify this some more. We're not going to do this. I'm not going to require you to do this in our class, but if you wanted to, you could split 64 as the 4th root of 16 times the 4th root of 4x. And I'm doing this because 16 is a power of 4. It is 2 to the 4th power. So the most simplified answer would be 2 times the 4th root of 4x. Again, for our purposes, I'm okay with you leaving your answer like that. Just recognize that it might not be completely simplified. All right, example 2, we want to write this in radical form. Now notice only the y has the root, or has the power on it. So y is the only part of our problem that's going to go under the root symbol. 7 has an implied power of 1. We can leave that as 7. Y goes under our root symbol. And our index is 2, and our power is 1. As mentioned above, when your index is 2, that's basically just square root. So it's 7 square root of y. Example 3. Let's convert the other way. Now notice only x has a power of 3 on it. 6 actually has an implied power of 1. So when we convert this to exponential form, it becomes 6 to the 1/5 power, because this index 5 applies to both the 6 and the x cubed, and x to the 3/5 power. Again, be careful, don't apply the exponent 3 to the 6. The exponent on the 6 is actually a 1. Example 4, we want to evaluate this expression. So it might help, there are 2 ways to do this actually. So let's see, method 1. It might help to, if you want to use this method, rewrite it in radical form. So this becomes the 5th root of 32 to the -3rd power. Now, it might be easier to do the 5th root of -32 first and then raise it to the -3rd power. So to find the 5th root of 32, you're really asking yourself, what to the 5th power is 32? And you should be comfortable enough with some of your bases to recognize that it's 2 to the 5th power is 32. So the 5th root of 32 is 2. And then we still have raised to the -3 power on the outside. Going back to our properties of exponents, this becomes 1 over 2 to the 3rd. which becomes 1/8. Now another way to do this is to recognize right away that 32 is a power of 2. So if you take 32 to the negative 3/5 power, you can rewrite 32 as 2 to the 5th. Now power to a power property says you can multiply these powers together. When you do, the 5's cancel out. You're left with 2 to the negative third, which, like the other problem, or the other method rather, gives us 1/8. All right, our final example here, again, we have a power raised to a power, so you can multiply those two powers together. We get 125 over 27, and when you multiply, we'll do it on the side here, negative 1/5 times 5/3. You can multiply across and get negative 5/15, which reduces to negative 1/3, or you may recognize that the 5's cancel out, which takes you straight to negative 1/3. Either way, this is 125 over 27 to the negative 1/3 power. Now, the negative flips our fraction, so we get 27 over 125 to the positive 1/3 power. Now we ask ourselves, can we simplify further? Well, maybe it would help to convert this to a root. So this becomes the third root of 27 over 125. Actually, let's back it up a moment. Let's distribute that outer power in. That's quotient to a power. So 27 to the 1/3 over 125 to the 1/3. So that becomes the third root of 27 to the first power, and the third root of 125, again to the first power. Now, can we find the third root of 27? Well, the third root of 27, I'll do it here, is really saying what to the third power equals 27. And again, you should be familiar enough with your powers to say that that's 3. So our numerator becomes 3. Our denominator is asking what to the third power makes 125. And in this case, that's 5. So our most simplified answer is 3/5. So using your properties of exponents and this idea of converting between radical form and exponential form, you can simplify expressions. This is standard 6.3, which is converting between rational exponents and radicals and also simplifying.